In the last video, we have discussed about a simple microscope. But here we want to discuss about a compound microscope. A compound microscope consists of two different lenses. One is called as objective lens. This lens is called as objective because this lens is in front of objects. And this lens is called as eyepiece because it is in front of eye. Therefore, a compound microscope consists of two different lenses. First one is objective, another one is eyepiece. Here we want to calculate the equation or expression for magnification produced by a compound microscope. Before that, I want to explain this figure. AB is our object. AB is our object, and considering two rays, one is parallel to principal axis, another one is passing through optic center. At this point, a real image is formed which is represented by I1, M1. So, object of objective lens is AB and image of objective lens is I1, M1. Object of objective lens is AB. AB is the object and I1, M1 is the image of objective lens. This I1, M1 will act as virtual object for eyepiece lens. So in the case of eyepiece lens, I1, M1 will act as object and I2, M2 is acting as image. So AB is the object of objective lens. I1, M1 is the image of objective lens, where I1, M1 is the object of eyepiece lens and I2, M2 is the image of eyepiece lens. Image of objective lens will act as object of eyepiece lens. Here we are going to calculate magnification. Magnification can be calculated as M is equal to height of image divided by height of object. We know the expression for magnification. M is equal to image height divided by object height. So from this figure it is clear that image, what's image here? The final image is I2M2 and our object is AB. So AB is the object and I2M2 is the image. Overall result. So M is equal to image height. Image height is I2, M2. Image height I2, M2 divided by object height. Object height is AB. Ready? Now image height is I2, M2 and object height is AB. Now this equation is termed as equation number 1. Here we are going to multiply equation number 1 with the I1, M1 and dividing with the same number. Therefore there will be no change. So M is equal to I2, M2 divided by AB into I1, M1 divided by I1, M1. So multiplication and division by same number, there will be no change in the final result. Here we are going to interchange the denominators. Denominators are interchanged. In the position of AB, I1, M1 will come and vice versa. Therefore, magnification is equal to I2, M2 divided by I1, M1 into I1, M1 divided by AB. I2, M2 by I1, M1 into I1, M1 divided by AB. Interchanging the denominators. So, from this equation, it is clear that I2, M2 is the image of eyepiece lens. I1, M1 is the object of eyepiece lens. So, image height divided by object height It is nothing but magnification of eyepiece lens, because I2 M2 is the image height of eyepiece, I1 M1 is the object height of eyepiece. Image height by object height, magnification of eyepiece, into I1 M1 is the image of objective, AB is the object of objective lens. Image height by objective height. So it's the magnification of objective lens. So total magnification will be the product of eyepiece lens, magnification of eyepiece lens and magnification of objective lens. From here we know two equations for magnification. First one is M is equal to V by U. In the last session we have discussed this equation. Another equation is M is equal to 1 plus D by F. This is the equation of simple microscope. So we know two different equations for magnification. One is V by U, another one is 1 plus D by F. So we can write one of the magnification with this equation and another magnification with the second equation. So M is equal to ME can be written by using this expression, and MO can be written as this expression. Ready? So first of all, MO, VO by U into, then ME. ME is 1 plus D by FE. MO is written by using the first expression. ME is written by using second expression. Ready? From here we are taking an assumption, an ideal situation. When is a there will be a point focus. If there will be a point of focus, if object is moved towards focus, I1 M1 will move towards eyepiece lens. When the object is moved, image also get moved. So when object is moving towards focus, image will move towards eyepiece lens. Therefore, if object distance is equal to focal length of objective lens, that means object is moved towards focus. Therefore, object distance is equal to focal length. Then image distance, image will move towards eyepiece lens. Here the distance is L. The assumption is that when the object is moved, correspondingly the image will also get moved. So if the object is moved towards focus, object is moved to focus, therefore object distance is focal length. In that time, image will get moved towards eyepiece lens. Here the distance is L. So object distance F, image distance L. Therefore, we can rewrite this equation. This will be the final equation. M is equal to V objective. Instead of V objective, we can write L by U objective. Instead of U objective, we can write F objective into 1 plus D by F. It's a final expression for magnification produced by a compound microscope.